In this video, we're going to learn about polygons. So what are polygons? So a polygon is a two-dimensional figure. It's a two-dimensional figure, 2D figure that's bounded by segments. Okay, so that means just take a bunch of segments and you put them together and you'll get a polygon. So here's an example. 1, 2, 3. I took 3 segments, joined them together, and I make a polygon. Now, one thing I forgot to mention, that it's closed, right? It's a closed figure, so the figure has to be closed. There's no open spaces. So this would not be a polygon because it's not closed, so I would have to close it. So here we have a triangle, here we have a rectangle or a quadrilateral, not really a rectangle. So I can do this. This here is a pentagon. There's 5 sides here. So, and I can also have polygons like this, like that. This is still a polygon, but this is a different type of polygon. This is called a concave polygon. So this is also a polygon. If I do this, like that, like that, like that, like that, like that, still a polygon. So it's closed and it's bounded by segments. So what is not a polygon would be something like this. If I do this and then, well, let's make sure it's closed. So there. This would not be a polygon if I use a curved. Okay, so this is not a polygon. Because of that, this here is not a polygon. Not a polygon. So what kind of polygons do we have? Well, we have these ones here are called concave. No, this one's called concave. Concave. This one too is concave. And these ones are convex. Convex polygons. Okay, so these are convex. So something like this would not be a polygon because it's not closed. So this one here is not a polygon. Not a polygon. So let's look at the 2 different types. So we have here, we have convex and concave polygons. So let's write that down. So what is the definition of concave and convex polygons? Let's just do something like this. Now here we have a 5-sided polygon. This is called a pentagon. And let's draw something like this over here. This one will be concave. Well, this one over here is also a pentagon. Now, what is the definition of convex and concave? Well, you can almost see right away what it is, but the real definition is this. If I pick any 2 points in this convex polygon, if I pick any 2 points and I join them, the segment joining those 2 points will always be inside the figure. So wherever I put this, it will always be inside the figure. If I pick a point over here and I pick a point over there, or over there, over there, the segment will always be inside the figure. Wherever I put it's like playing telephone. Okay, so if you're playing telephone, imagine this is your backyard and you're playing telephone. You're standing over here and your friend is standing over there. The rope or the string will always be inside the figure, no matter where you stand, no matter where your friend stands. Okay? But in a convex polygon, I mean a concave polygon, now we're talking about concave polygons, it does work sometimes. Okay, so it does work where you're standing here, but it doesn't work everywhere. So if you're standing over here and your friend is standing over there, then the string is outside the polygon. So this is why it's concave, because the string is outside the polygon. Even though sometimes it can be inside, but if there's at least 2 places where the string goes outside, it's concave. So if I go back over here, see this one here, concave, because if I'm standing there and your friend is standing there, the string is outside. Whereas these ones are all convex because you can stand, or the segment is always inside. Another way of thinking of a concave polygon is a cave, right? You have a cave, so this part over here is kind of like a cave. So if you're standing over here, and your friend is standing over here, well, you're hidden in the cave. You can't see each other, so you're kind of hidden from each other because you're in a cave. So that's one way of looking at it. Whereas here, there's nowhere to hide. Wherever you are, if you're standing over here, your friend can see you wherever you're hiding.